Hello, my name is Rick Marshall. We're here at Solano Community College, and today we're talking about automotive batteries and how to test them and determine if we need to replace the battery as we start our electrical diagnostics. So if you see over here, we have a 2005 Pontiac G6. And if we come on over to the car, we'll see it's got an AC Delco battery installed in there. I'd like you to pay attention on the top of the battery. You'll see the plus and the negative. And if we come over, it's a side post battery. We'll see the colors match, but they don't always when you're working on a car. Red may be negative, black could be positive if someone's changed the cables. On the top of the battery, we have a label giving us our cold cranking amps, and behind that is 90 reserve capacity. That's 90 minutes at 25 amps we can drain out of this battery, and it should still start the car if it's a good battery. Most batteries will only have the 650 or whatever cold cranking amps it's rated at. And most batteries will also have a little round sticker, kind of like kids play with a date. And that's the date the battery was manufactured. That's a little bit of info on that we need to test the battery. Now we're going to decide, is it fully charged? Is it any good? And some people will start with their digital multimeter. We have a Fluke here. Turn it to DC volts. Hook up our leads. And we're 12.48 volts. Remember, 12.6 is fully charged, 12.0 is 25% charged. Below 11, we end up being completely dead. So this battery is almost fully charged. But that only tells us it's charged, not that it has any capacity to actually start the car or help the car. So we're going to do a couple testers here. We're going to do a conductance tester as well as carbon pile. These are more known. If you work in any of the industry, you'll have ones of these that may say Toyota, Honda, Nissan. They're usually made by Medtronics. This one's made by Madco. Real simple to use. You hook up the red lead, the black lead, the thing powers up, and it starts asking you on the battery, is it in the car, out of the car? Then it comes and asks you, is it conventional or absorbed gas mat, gel or spiral? Spiral is an Optima battery. Absorbed gas mat is a gel. Conventional may also ask you is lead acid, or it may ask is it a regular battery. Any battery in the passenger's compartment of the car, under the back seat, in the trunk, has to be absorbed gas mat for safety. If the car is rolled over, we don't have lead acid running onto the people in the car. Go is our enter button, so we enter go. Shows our voltage. Now it asks, how do you want to test it? Cold cranking amps, cranking amps. So we're going to always test cold cranking amps. 650 matches. If not, you have to adjust that. If you put the wrong reading, you're going to get the wrong test results. Push go, and now it is load testing the battery. We'll see it takes a few seconds here to run a few calculated tests. Remember, these testers are calculating what the amperage of the battery is. When we get to the carbon pile, it's actually testing. Here it asks us the temperature outside. Is it below 32? We go no. Proceed with starting and charging. No again. And now we see it says battery bad, 12.4 volts, 297 cold cranking amps, and it's supposed to have 650, so it's less than half of the amperage to actually start the car. Here's where we would print it or take a picture, give it to our customer, and sell them a battery. The reason this is important, this car starts completely fine every time. It's my car. I've been using it, but eventually it's going to die. So when you inform your customer of this and they choose not to buy the battery, when it doesn't start, they'll know you're a good tech and you're being honest because you tried to sell them a battery. It's not dead yet, but it is going to die. Another tester here, as you see this snap-on, this is real common, or real similar to what they call a GR8 with some of the imports. This charges the battery, can test the battery, can test starting and charging systems. But similar again, handheld, we can take this off. We need the whole box if we're actually charging the battery or testing, starting, and charging. We're going to hook up the red lead to positive, black lead to negative.
Snap-on electrical system diagnostics.
And it talks to us. Wow, I'm impressed. So we wait for the menu to come up. We look at the picture of the battery, battery test. The S is our enter button. So we push enter.
Battery test.
And it tells us it's a battery test. Customer ID, if you have a repair order and you're logging this at a shop, you can put the repair order or customer's last name. We're going to bypass. In vehicle or out? We are in the vehicle. It's a side post. It's an automobile. and it is lead acid and cold cranking amps. 650 it matches, so we push go ahead. It says hold it above 2 inches above the case, push the right arrow for next. It's got an infrared thermometer. Now it is testing, and we should get the same results.
Charge and retest.
This one's wanting us to charge it because it's not fully charged and retest the battery. The nice thing with these testers, when the car comes into your shop, if the battery isn't fully charged, you can actually still test it, and it may tell you bad, it may tell you to charge and retest. Where when we go to our next tester, an actual carbon file tester, which is over here, this takes a little more work. We have to do a little math, we have to do a little thinking, and if you ever test a battery that's not fully charged with this tester, it's not going to be able to tell you correctly. It will say it's bad. It has to be fully charged. So again, we have a red and black lead, hook them up to the battery again. And the green lead here has an arrow pointing to the positive. We can hook it around here. It doesn't really matter. Remember, this is showing the amperage. This is actually pulling the current out. This is just so we can see the numbers. And if we're testing the starter or charging system, this will be down on the battery cables instead of on the tester's cables. Now we should have readings up here, or we don't have a good connection. There we go. We have 12.4 volts, so we're about 75% charged. Remember, the battery was 650 cold cranking amps, so we have to divide the cranking amps in half, or by 2, and that's what we're going to dial the amperage up to for 10 seconds and watch the voltage reading here. So 650 divided in half, 325 amps. We're going to dial it, count to 10, measure the lowest voltage reading. And now we're at about 6.2 volts. And if we need to know the spec, it's also on the machines. It's got to stay above 9.6 volts. We were way under that, so this car definitely needs a battery, without a doubt. So, and now we see that it pulls it out. After you do 2 or 3 tests on this car, or any car, you will need to charge the battery because this is actually pulling amperage out instead of doing calculating. So while we're talking on that, let's talk on safety. You saw I have safety glasses on, I have gloves on, but let's talk on charging a battery. Here we have a battery charger. We're going to pull up here. And what most people do is they pull the battery charger and they plug it into the wall. That's the first mistake. This never gets plugged in until it's hooked to the battery. And there's a couple reasons. The last person forgot to shut it off. These are hot and they're going to arc, possibly explode the battery. The other reason is the knobs act up on almost every battery charger and they stick. So we connect this to the battery first. Then we plug this in the wall. I'm not going to actually plug it in right now. We plug it into the wall, then we can turn it on to charge. Then when we're done, we never unhook it from the car. We unplug it from the wall, then unhook it from the car. That way if this dial, and actually this dial is about 1 inch off of working accurately already on a new charger. If they stick, you don't have an arc, the gases from the battery don't explode. That is properly charging the battery. How much do you charge it? You got to calculate that by reserve capacity. This one here comes out to about 8 to 10 amps. Charging it more than that will work faster, but slowly damage the battery. So that is battery charging, and thank you.